What is up, team? Welcome back to Stats. Welcome back to Virtual Learning Day 5. This video is actually going to serve as a mini lesson. You can talk about them as like mini notes. But today I'm going to be going over some of the stuff that was in the chapter that you were supposed to read, chapter 17, about probability models, and discuss a little bit of the nuances and different ways of thinking about some of the material. So let's go ahead and let's get started. Let's get distraction free because that's the way to be. Let's get ready to go. Grab your notes, grab the textbook chapter so that way you can read it along with me, and you can clarify anything. Feel free to pause the video, go back, go forward, zip through the pieces that you feel are important to help you learn the best way you can. But for now, the actual textbook chapter, chapter 17, starts with this concept called a Bernoulli trial. And a Bernoulli trial is going to be the basis for our understanding of probability models. So what is a Bernoulli trial and how does the book describe it? How can we think of it and how can we get going? Essentially, when a certain situation happens, either the thing that we want to happen happens or it doesn't. So a Bernoulli trial actually has a couple different criteria in order for a situation to be called a Bernoulli trial. Part of the criteria, we need a success and a failure. More specifically, is there's only two possible outcomes in a given situation. For example, if we flip a coin, we either get heads or tails. If I want to reach into a bag of mixed colored marbles and see the odds of me pulling a green one, it's either I pull a green one or I don't pull a green one. So when we say two possible outcomes, there's actually a specific way we talk about that. First, it's either a success or it's a failure. Now, for success, we can actually talk about the probability of success labeled as P and the probability of failure labeled as Q. If trials are independent, I want you to think really quick, what does that actually mean? If you said that the outcome, oh, here I go again, misspelling. If the outcome of one, I'm going to say trial, or we can refer to that as an event, does not affect the outcome of another. For example, if I talk about the problem with a bag of marbles, I have a bunch of colors of marbles in a bag, and I want to have the probability of me pulling a green marble be considered my success. Anything else will be a failure. In that situation, if I reach into the bag and I pull out a green marble, congrats, I just succeeded. That's not quite a Bernoulli trial though, unless I put the marble right back into the bag and where it came from. If I continuously replace that marble back into the bag, we can call it a Bernoulli trial because that would make sure that our outcomes are independent. I have the same likeliness of drawing the green marble every single time. If I reach into the same bag and I pull out a green marble and I say, great, I succeeded, and I put that marble off to the side, I lost my independence because now the odds of me pulling another green marble changes because there's one less. Given that we have a Bernoulli trial, there's actually two ways that we can model the different probabilities that are coming away from that situation or scenario. The textbook chapter actually describes two different models that we can use to explore the probability of something occurring, given that it's a Bernoulli trial. The first way that the chapter explains is using a model called the geometric model. Now, keep in mind, this has nothing to do with geometry in terms of shapes, circles, squares, triangles, areas, perimeters, anything like that. Different type of geometric, and this model isn't us building a structure, It's modeling the way that we can do the probability, do the math to determine the outcome of something. The second way that the chapter describes a model that we can use given a Bernoulli trial is called a binomial model. We need to know way more than just the different names, geometric and binomial. We actually need to know how to distinguish when to use the different models that are presented in the chapter. And if you read closely, you would know there's two different questions that we can ask ourselves in order to distinguish which model we should use given a certain situation or scenario. Starting with the geometric model, the one question that you can ask yourself is, how long will it take for me to reach my first success? Using this question, we as learners are trying to discover, hey, how many times do I need to run this trial for me to get my first success, for me to succeed for the first time? Now, this question, we're actually looking for how many trials will it take? We're searching for the value, which we'll consider in a little bit, n, to determine how many trials will it take for me to get to that first time that I actually succeed. How many times should I expect to reach into the bag in order for me to pull out a green marble? So this question will help you distinguish whether or not to use the model, geometric, versus a binomial, which has a different question that we can answer. In the binomial model, the question that we can ask ourselves is, how many successes will I achieve in, I'm going to call it n, we're assigning it a little variable, n trials. The difference here in a binomial model is that we're looking for how many times we actually succeed given that I've run a trial a certain amount of times. So going back to the marble example, if I said I were to pull and replace marbles 10 times, how many times should I expect to actually succeed? There's subtle differences in the two, but we're going to use them in different ways and discover how can we best think about a problem like this. Make sure you add this to your notes because these two questions can really help you answer the exercise problems at the end of the chapter as fast as you can to determine the difference between the two. Just like the last unit, we'll be asking ourselves, hey, how many times should I expect to run this trial before I reach my first success? We're still considering the expected value piece. This time we're using a different type of model in order to assess that question. Each model actually is going to use different pieces of information in order for you to determine the answers that we're looking for. So let's start with the geometric model. What do we actually need in order for us to solve this problem? Well, for a geometric model, all we need is the probability of success. We only need one piece of information, and that's the probability of success. With that one value, we can determine a lot of things out of that. The probability of success is denoted with the variable p, and we can use this to actually determine the probability of failure. In fact, if we were to look at this, the probability of failure is equal to the variable q, and in this case, q is going to equal to 1 minus the probability of success. Just like the math that we've been working through this entire year, if we know that the probability of me flipping a coin heads is 50%, the probability of me failing that is flipping tails, which is also 50%. 1 minus the probability of me flipping heads is equal to the probability of me flipping tails. On the other side, for a binomial distribution, or binomial model, we need one more piece of information. We also need the probability of success. Which we call P. But we also need to know the number of trials. Which is denoted N. If in a binomial model we're trying to figure out how many times we succeed, we need to know how many times we're trying to do that thing. With these two models, if we have this information and that information, we're able to solve the problems using the formulas given to us in the chapter. Let me erase this and show you those formulas now. For a geometric model, we're still talking about the expected value. How many trials should I expect to run in order for me to succeed for the first time? Expected value is denoted E of x, which is still equal to mu. It's like a cursive U. And in a geometric model, it's actually going to be 1 divided by P, which is the probability of success. Similarly, if we're finding the expected value, we can also find the standard deviation. Now, unlike our last unit where we had to go through all of the problem-solving process, here it's a little bit of an easier equation. Standard deviation, we're still going to use sigma, is equal to big square root of Q over P squared. Now this is where Q is the probability that we're failing. So we're taking the probability that we fail, dividing it by the square of the probability of us succeeding, and then taking the square root of that whole value. The binomial model also uses the expected value, or the mean, and solves the problem in a similar way. Except this time, remember, we need to use N. We need to use the number of trials because we want to know how many times do I succeed in a certain amount of trials. In this case, we're still finding E of x, which is still labeled as mu, but this time it's going to be the number of trials multiplied with the probability of success, which in this case is pretty intuitive. Given a certain number of trials, I'm going to multiply that with the probability of me succeeding, and that should tell me how many times should I expect to succeed. If we think of this with flipping a coin, if I flip a coin 10 times, and the probability of me flipping heads is 50%, I should estimate I'm going to have about 5 successes in those 10 trials. To find the standard deviation here, it's going to use the same values as before with N and P, but this time we're going to incorporate Q into the mix, the probability of us failing, and it's going to be the square root of the number of trials multiplied with the probability of me succeeding and the probability of me failing. If you have any questions or comments, you can certainly email me, you can reach out, and we can get a good clarification of the nuances behind these problems if you really want to work through them together. But for now, hopefully this helped clear up a couple different things for you and helped you get started on the assignments that I assigned you. Get ready to go for Virtual Learning Day 5. We're going to have a lot of stuff to talk about and then push forward with the next assignment. Hope you all have a good day. I'll see you next time.